final speaker for this afternoon's inaugural Innovation Speakers Forum. And delighted you could join us for this. Today we are honored to welcome executives from businesses here in Skagit County doing very innovative products, services, and introducing very innovative ideas right here in Skagit County. And our fourth and final speaker today is Andries Breedt, owner and chief engineer of Breedt Production Tooling and Design. Located in Kent, Washington, BPT Design is a small business that impacts productivity for some of the world's largest manufacturers, such as the Boeing Company and Kenworth, as well as companies like Blue Origin. And the company has recently expanded here into Skagit County and is already making its mark with some exciting work being developed at its new R&D center in Wacono. We're going to do something a little bit different with this presentation. We're going to have more of a discussion with Andries, and then after we've discussed a few questions, we'll open the floor to a broader conversation. With that, Andries, I'm delighted you could join us here this afternoon. And please tell us a little bit about Breedt Production Tooling and Design. What does your business do, and what industry sectors are you in?
Hello. As you heard, my name is Andries Breedt. For some people, a funny name, but its origination is from Dutch, and it's the same name you guys call your Andries. It all comes from that same name. So, tooling engineer, that's what they call me, and that's what I trained to be. I went through a long time at school being that guy, and if you show the next picture, give you idea. This is what it used to look like. You know, you were in paper and a design board and a sliding rule and a logarithm book in your pocket. That was your tools as an engineer. So I started school in 1969, just after my boot camp training in South Africa. And then tried to do a lot of things in my life. I went through a 15-year training with a German engineering school. It sounds very long, but it happened. Made a lot of things since '95 in the USA, as well as in Africa and Germany, well, everywhere. I have a footprint a lot of places. So in that left-hand corner is a car parts that we designed. It's a manifold, the intake manifold using the golf ball technology. The little knobs on the golf ball that makes it go so fast and far, we did it in our manifolds. You R&D guy for Packard, so you will know, faster the airflow, stronger the motor is. So we got like 400 horsepower from a 4-banger engine. So little ST Ford, and then we have a full automated shop with all kinds of CNCs. I do not do big production runs, but a lot of R&D work. I designed the frame that you flip your chassis in Renton. It's one of the designs. I made the tool that put the truck together, the whole truck, that two of them. Yeah, we machine shop, we do CNC machining of all these manifolds, shift arms, tooling for Boeing, a lot of things. I cannot tell you what I don't do, many things. So you can ask the next question. Name it and we've done it.
So this is a great segue in. Your company has recently expanded here into Skagit County, and what products do you plan to manufacture here, or what are you already doing here?
It's hard for me to say what I'm gonna manufacture. Actually, what I came here for is to use my boat more often and go crabbing. But last year I did not have time to leave my computer. I got my computer screen is like that. And I was sitting there all summer and nights also. So I was designing this machine here. Since I'm here, I got this RFQ or not RFQs, you're gonna do it. So I had a napkin with me, piece of paper, went to Herzog. It's a company it's a big glass company in Seattle, and Herzog, I think it is. So their crew bought this machine off me, and they gave me a few points of that I have to do. This machine, amazingly, needed to climb 32 feet high from one platform down and up after it's done. It did the down right now. It's already done that part, and was challenging. So what I did, this legs here comes out, and this I designed a lifting machine that goes into the same place as the legs. So we put the machine down, move it into it, and then a hydraulic system lifted the machine up higher than a ramp that's first put onto that ledge, and then we drove it over because it's got a wheel system only 1 inch off the ground. But it also have a jack system in the middle, so when we put it down on a very thin floor, the challenges was amazing. It have a sheet metal, corrugated sheet metal floor with about 4 inches of concrete on top. And then it got the girders or the beams every, for 8 foot, I think they were apart on a 15-degree angle as it goes around. And that's all I had to work and put an 8,000-pound machine on it. And then also I had to put a glass, this glass here weighs 2,500 pounds. For any engineer thinking about that, I mean, this doesn't make sense in math. Does not at all. So I started off, I had 6 weeks to build this machine. From the minute that I started, I'm the only engineer on it. I'm not bragging, but I did it. So I started, I had to think about this thing really good, few nights for it. And I decided I'm gonna do this in a laminated form. So I'm gonna take aluminum plates, lay it layer by layer, and then if I need to change something, I could take one plate out, put it on my water jet, cut quickly out. So all was done with technology. Nothing handwork. This machine was built by technology, water jet, CNCs, hardly any machining, very little machining because it wasn't time for that. So this is the end product. This is in my Kent shop. Each one of these cups can lift vertically, is it 1,000?
I think it's horizontally it's 1100.
Sorry, I have to.
And vertically it's 500.
Yeah, I have to ask my assistant because why I asked her this question because she was sitting in her office. I was downstairs in my office for 6 weeks. She was researching the whole world. In front of, you can't see it now, behind this thing is a steel wrist, a piece that can turn and maneuver by a computer in a millimeters, less than a half a millimeter. So you can move this glass slightly up, down, angles, everything, because the frame is pre-manufactured. So we have to take this piece of glass, swing it around, and it's 500 feet right down over the end. So it was kind of scary. So I did not know. There you see the first glass installed. We had a hard time doing this year because that was kind of windy. It was very windy, it was raining. Any 2 digits of wind, we could not bring a glass out. I didn't do it. I was working on the next project, which was here in Skagit, which was robots for Finland. And I had to finish that also. So it was even faster than this one. So it was kind of a busy year for me. There is the machine, beautiful background.
All almost done.
Almost done. It's got, Monday it had 19 more panels to go. So by now, I don't know, we had a couple of good days. I'm not there every day, so I don't drive the machine. I just worry about it. Okay.
Think about this the next time that you visit the Space Needle and see the great work this machine has made happen there.
Yeah, please go. You guys can go now. You can go up there and there's special fields. You can see the machine. Oh, sorry. sorry. I can forget. But anyway, so you can walk around and see the machine working over. This is the main reason why I came to Skagit. What we see on the board, I had this order, I would say, from Governor Ainsley. He wanted to create material to replace tires on the Skagit. Not on the Skagit, on the Dowanas. And that was his first goal. So I worked 8 years on this thing, only 6 weeks on that machine. It was actually much more difficult. Sean knows we met one another. Actually, first time we were presenting this thing in Germany, and my goal at that time was searching for material. I had the design done, but I didn't know what material to use. So that was the biggest issue on this thing, was material. The next thing is, I believe, and I do believe, Professor there can tell you, I do believe history is the only thing that made me do what I do today. If you don't study history, you cannot remember. So I remember from my German teachers was, everything we do, if we take a cutter, they tell you who invented that cutter, Malinka. Why is it invented? Why was it made that way? And that's how you remember. You never forget that story. So this thing here, I used unknowingly. The thing that many people never ask the question, if you take your grandpa's drill chuck on his press drill, and you put it up in the chuck and it sits there. But no one asks why. Because the paper alone cannot make that thing sit there. I don't know who of you guys are engineers here. Put your hands up, I would love. Yeah, I know him. He knows some of my projects. So the thing is, there was a German guy with the name of Morse. Many people that studied math knows Morse. Mr. Morse decided that an angle smaller than 6 degrees, I think it's 6 degrees, I don't know. That angle, if you just bang something with a slight hand pressure, that will sit there. And more load you put on it, just sits better. And you want to take it out, you can. But there's a slot on the side, on the top of the taper. You put your drift in there, and you give it a bang, and there the drill jumped out. And that's an amazing invention. I say today that Morse didn't invent that. Because I found out driving through Germany on these trips with the farmers that there's a lot of these bridges that still have the keystone on it. There's no model. They just took rocks, packed it in a circle till it hit the bank of the river, and then they put a keystone on it. And that helps, and that gives you a load umbrella. So when you put load on top of the bridge, the load is spread all around. That bridge is sitting there for some reckon 6,000 years. You know, most of them were still in use. It's about 4,000 years old. We built bridges 100 years ago that's falling apart or flying like airplanes. So I don't think most figured it out. It was the Romans. But he made the math. He got a formula. So this bumper here is this is a marine fender, you may call it, or a rubber bumper for ships. So each one of these quadrants has got a taper in it, Morse taper. And they're all made out of the material that I eventually found in Germany by accident, made by, it was under the ocean for 30 years already, and no effect on the environment. So the material is EPDM 513, they call it, Italian, German combination of a few European countries work together and creating that for the energy towers in, on the ocean, the wind towers, to bring the power to the mainland. So that material has been found for a long time, but we didn't know, and I didn't know. And here I walk by a stall and I see all this rubber extrusions at the Hanover Messe, and there was Thomas, a very good friend today of mine, German guy, and he's got this M&R products which make all kinds of extrusions for window seals, anything under the water, doesn't deteriorate, and take tremendous minus degrees, plus degrees in cold water, ice doesn't do anything. So I found this material, and today I own the only right to bring that into the USA. So anyway, the material then brought me to this subject. I'm a tooling engineer, so I know rubber, compression molding, and plastics, and I've been around the motor industry since 1969. So there's everything in a car, more than so there in an aeroplane. He can tell you a truck, it's a difficult thing to build. But anyway, so what I did is use that material, came up with new tooling, because there's never been a compression mold made as complex as this thing. If you see it inside, I forgot your name, sorry. But anyway, so that tools are complex. It's not an engine now. These things, one of them, this one here, have metal inside, just like a engine mount, but a ridiculous, funny design, so it can take impact of a barge running with that against a dock. Where are we now?
There's a hoop inside
Where?
This is the hoop.
Oh yeah, this is the metal part. I just built this in Skagit because I got an order to make a bunch of these things, and I make them in Germany, not that yet, but in Denver, because that's the only place where I could find a big enough press to press these things like 500 tons, rubber. So it's a complete thing. I went back to school in Milwaukee for a short educational trip with experts, American experts on rubber compression. And when I brought this part there, I sent it ahead of me. The whole course went on that part, because that was the professors that run it, they'd never seen a part. And it wasn't smartness, it was a must. I had to make that part. It took a lot. I mean, I even made for this part here, it's two halves. It's hollow and it can float. But one half takes 6 plate rubber mold to produce. 6 plates, every plate have a different piece of foam in it. And to strip this thing, I couldn't strip the parts because it's impossible after forming. So I had to make a automated mold stripper with hydraulics. So I could strip maybe the second plate at the bottom, and then I can strip the one on top and the one in the middle, and eventually the whole part comes out. You couldn't do it in a manual machine. The computer needed to help you to do it. And the upper one and the lower one is different. So it was kind of a challenge. So anyway, so we started testing. We had Fish and Wildlife approved the bumper. We had Northwest Science. It was Northwest Science, but they tested in fish in tanks. And they had salmon juveniles in 3 tanks. One tank they had clean water in, one tank they had tires in that was in the water that we took out and cut pieces of, and one tank We had my EPDM pieces cut so we don't have a seal or some, and all the fish in the road tires died, which we have on all our docks. Go to any dock here, you will find a tire on it. And we talk about clean, that's the worst thing. And you know what the problem is for it? The tire company, there was a thing out that they said no more tires on the water after this testing. It wasn't a week or what later, then the tire companies had a lawsuit and they won it because they had money. so, so it tells you, I don't know where we have to start with our cleanup. That is really, tires on the water is something unbelievable.
Andries, this is a great segue into another question, and you know the nature of the bumper and the green fender you're working on. It's environmentally friendly. It's a green product, and those are two things that certainly mesh well with Skagit County, given the very long maritime history here, both in fisheries but also in maritime manufacturing, and also the increasing emphasis here on clean technologies and sustainability. And so I'd like to shift into the question. You know, you mentioned some of the reasons why you're interested in coming up here to Skagit County in the first place, but what makes Skagit County an appealing place for you and your company to be doing business?
Well, the most appealing thing that I have here, obviously, is the beauty of this area. The second one is I'm glad that they developed Seattle and not this harbor in Anacortes. So that's one of the main reasons. And then this has got a harbor here in Anacortes. Skagit, the harbor of Skagit is the ideal place for export. So we can export this bumpers as soon as it takes. Maybe after my life, it takes a little bit time for people to realize this is what we need. You know. But it doesn't matter, it will come. We're going to manufacture them here in Skagit. All this machinery that I already designed and that I already invested in a lot of money, I'm going to bring over here. I already showed you guys the first foam tool that I bought, which was costing me a fortune to make one of that hoops that goes into the pile protector or the bumper, other one. I made a tool here that does it in 2 minutes. One operator. And we can also provide training, especially for high quality tradesmen, which we don't have. Any one of us that runs a business know this is our problem in the USA. We have lots of engineers. We have too many attorneys. We have, yeah, it's the truth. I mean, we don't have work for them all. I have students that I work from since the day I'm in United States. I started to see the problem, and I started to take young engineers out of the colleges and let them intern with me to learn how to make things. Because I don't know, I did apprenticeship. I did a full 5 years plus my engineering degree. Like John can tell you, that's what we do in Germany and other countries. We have a need for those people. We need some more Henry Fords, you know, which didn't have that high education but had a God-given talent, was machinist. They started the big businesses of this country. And we have a shortage of new businesses pop up. So I think my idea is for the Skagit, there's very disciplined kids here. I am very interested in youth. And it's my goal, like I was taught by my German mentors, you have to train 10 people in your lifetime. That's just as good as you or better. And we don't believe in the better. We want to be the guy. You know, you have to look at the future. And there's nothing wrong with the kids. I just told you earlier, right? But there's nothing wrong with the kids. I always thought the kids have no, I call it discipline, but I know you cannot say discipline here because you guys use the word discipline different than what British guys use it. Discipline doesn't mean punishment. Discipline means education in soft skills. But every 1 year, I only found it out now. If you say discipline, the people look at it. So I said a sense for reliability. And then they think that so just have a sense for reliability. It's the same thing as discipline, but they take it up easier. They don't need to take so much water with that tablet. So, but I have students here that really do good, that I mentored from high school. I got a couple that was going to be high school dropouts. One is doing his doctorate now because he was going to do the wrong thing. That he was going to do the wrong thing. He wanted to go to university, become an engineer, and his mom said so. Or an electronic guy. But anyway, he's now one of the guys that developed the self-driving cars. And I feel proud about that type of guy. So this is my story. The Skagit is really the place to be. Sure.
Thank you. Let's open the floor to questions.
So Andreas, when you think about, I mean, the one that comes to mind is Tesla. And you see how much automation that they want on their production floor. Is that a market you guys are looking into at all, or not?
Not.
Okay.
Because Alan Moss was born in the same town where I was born, in South Africa. So I don't know if you knew that. Yeah, so automation is an old thing for South Africa. We built the first automated motor car line in the 60s for Mazda. And there was not the electronics of today. It was difficult to build. It was Sigma Motor Corporation. You can look it up. We built every car under the sun, from Citroen to Mazda, but Mazda was the first automation line. And I tell you what, Alan Moss, what's his name? Alan. But he, just this morning, I read an article about him. He decided now to cut his automation. He recognized I made the biggest mistake of my life. Elon Musk. He read it's in the newspaper this morning. I read on my laptop, not my laptop, my iPad there. But anyway, he said that he wants to cut down the automation to automation can be a holdup. It's good, but it can be a holdup. What we did with the Mazda line was very profitable. It was semi-automated because there was, between every station, there was a man or two. And that works better because things go wrong. I worked with the Kenworth plant for years, very modern plant. I was very surprised when I saw this plant in such a small footprint. And it's double story. I've never seen a truck plant going up and down. I've been up and down that line a million times. I love that line because it's semi-automatic. I built a CNC machine for them to flip the frames, and that machine had to do, I think, 21 or 22 different trucks. You will know how many it does. I had a headache with that thing because every time I start designing the thing, and I made it to do this truck and that truck and that truck. And the engineers came back to me and said, no, they forgot, there's 10 more, we do one every second year. So it was but the semi-automated is better than fully automated. Give you another thing. Sorry, quickly. I bought a machine for Harley Davidson on that question to make muffler tubes. And the whistle inside that gives it Harley Davidson that certain sound. And they wanted to offshore the parts. There's 5 different Harley Davidson engines at that time when I bought it. So everyone had a different size exhaust pipe. So they came to me, can you build something that can make? So I did. And I built a machine that makes double, oh, not double, I don't know how many times, but 1,000 different tubes every day. It was a desktop, you put one tube you move pencil like this and put it in a pen like this. Where it was used to be a very, in China they would have rolled the hole and it would have taken too long. And the cost was low, but my cost was half. So that's why I believe we can fight the problem of offshoring by ease. Because we have people in this country that can design. If we can design machines to make it half the price is what we can buy at auction. And I have proofs. If you want to see pictures, I can send.
Maybe to wrap things up, Andres, could you tell us a little bit about this, what you have in the picture here?
Oh, it's the most beautiful picture in the world, right? So this piece of art, I'm a keen diver too. So, and I'm an artist, and I thank God for that. It's not because I didn't become an engineer. I was engineer born. I had to go to school to learn the terminology of certain things, but I was already there. But this thing, when I went to aptitude tests through my young years, which we don't do here, they all told me, you got to become an artist. And I said, no, I want to be a race car mechanic. So, but anyway, so I always have art, and I eventually got through the school with a German mentor. He jippled my papers, and he said I can become a tooling. So that's what I am. But this, I dived, and I saw the die off of the starfish in the Northwest. Don't know if you guys know about the wasting disease. So before, years ago, I could dive anywhere in the Sound and see banks of starfish, and they were everywhere in every color. The most beautiful starfish in the world we had here. We don't have that anymore. So it really hurt me, and I was inspired by that to build this art piece that 3-4 years ago. I just went in on a Sunday, grabbed a welding machine, the little discs came off the water jet aluminum pieces, and I started welding it together. I didn't know what it's going to be. I went to a art commission meeting, they invited me, and she was art commissioner. So I asked, they asked me, what are you making? I said, oh, I'm busy with this thing, and I had water base there. I didn't know what I'm going to do. And they asked me, where is it going to go? I said, no, I think I'm going to make a little thin metal, looks like a sexy metal. So I started welding again, and it turned into this base. And then I thought I should do the starfish. So on this thing is many starfish. Inside is one that lost a leg already. You got to read up about this. I think on the flyers from NCF, you can go online and read the whole story about the starfish dying. So now, if you guys want to, there's invitations. It's now in the Anacortes on the waterfront. Gonna be the entrance to the park, the new walking trail all around Anacortes. So that's going to be the first art piece that's going to go there. And feel welcome to take it. Every starfish there, I modeled to one that I got. So they are all not old school, new school. I did it in SolidWorks. And I kind of modeled it. And every one of them has got a name too. So please go and look at it. Thank you, guys. I think any more questions, quick one I want.
Andres, thank you very much for joining us this afternoon and introducing your company and all the really exciting things that you're doing. We're very excited to have you up here in Skagit County and look forward to your growth and expansion and exciting new partnerships.
Well, I am very happy to be here, Sean.